All right, have you ever stopped to wonder what actually makes your smartphone so smart? Or how your computer, well, computes? Today, we're going to dive deep into the absolute heart of all our modern gadgets and uncover the magic that makes it all work. We're talking about semiconductors. Think about it for a second. Everything from your phone to your car, even your watch, it all relies on controlling the flow of electricity with this incredible microscopic precision. But how in the world is that even possible? Well, the answer starts with the materials themselves. Okay, so the whole story really starts with a simple but super powerful idea. Different materials handle electricity in three fundamentally different ways. And understanding this is the very first step to controlling it. On one end of the spectrum, you've got conductors, like copper wire. They're basically wide open highways for electricity. Then, on the complete opposite end, you have insulators, like rubber, which are total brick walls. Nothing's getting through. But what if, just what if, there was a third kind of material, something in the middle, kind of like a road with a gate that we could learn to open and close whenever we want? That's where the real magic happens. So what's the deal with this Goldilocks material? The one that's not too conductive but not too insulating either? What makes it so special? To really get it, we need to look at it in its purest, most basic form. So in its pure, or what scientists call its intrinsic state, a semiconductor is, well, it's kind of useless, actually. It's perfectly balanced, it's electrically neutral, and it just doesn't do much of anything. And that, right there, presents us with a pretty big problem. So the big question is, how do we hack this perfectly balanced, neutral material and turn it into the powerful tool we need for controlling electricity? The solution, as it turns out, is a stroke of absolute genius. Okay, let's get into the technique that really unlocked the incredible power of semiconductors. We're going to see how this one really clever trick is the foundation of our entire modern world. This trick is called doping. And all it means is that we intentionally add a tiny, precisely calculated impurity into the pure semiconductor. Now, this isn't about making it dirty or contaminating it. This is about transformation. It's how we seize complete control over its electrical properties. By doping with different elements, we can create two new flavors of semiconductor. If we add an element that has one less electron in its outer shell, we create these positively charged gaps, or holes. We call this p-type. But if we add an element with one extra electron, we get these free-floating negative electrons, and that's called n-type. So now we have two distinct building blocks, and the real power gets unlocked when we put them together. All right, pay attention, because this right here, this is the absolute core concept of everything we've been talking about. Because when these two different types of doped semiconductors meet, something really incredible and profoundly useful happens right where they touch. What we do is we physically join them. This creates what's called a p-n junction. It's simply the meeting point of our two custom-made materials, the one with extra electrons and the one with extra spaces for them to go. And the second they touch, bam! The free electrons from the n side just rush right over to fill those empty holes on the p side. This creates this neutral, charge-free zone right at the junction, which we call the depletion layer. This layer acts as a barrier, and that barrier, that's the key to everything. See, this barrier is special. Think of it like a one-way street for electricity. It allows current to flow super easily in one direction, from N to P. But if it tries to go the other way, nope, total brick wall. And just like that, we've built a diode, an absolutely essential electronic one-way valve. Okay, so now for the huge payoff. How does this simple little one-way gate become the building block of the entire digital world? Well, it happens when we get a little more creative with our ingredients. By combining these junctions, we literally create the single most important invention of the 20th century, the transistor. The easiest way to picture it is to think of it as stacking our p-type and n-type materials into a little three-layer sandwich. For instance, a really common type is the NPN transistor. You've got two layers of n-type material, and squished right in between them is a super, super thin slice of p-type material. That little middle layer, which we call the base, that's our control gate. So here's the absolute bottom line. A transistor is just a tiny electronic switch. And the coolest part? A tiny little bit of electrical current sent to that middle layer can control a much, much larger current flowing between the other two layers. It's a switch with zero moving parts.
And when I say tiny, I mean it. These switches are mind-bogglingly small and unbelievably fast. A single modern processor chip, the kind that's inside your phone right now, can have over 50 billion of them. Let that sink in for a moment. Billions of them, switching on and off billions of times every single second.
So you see how it all connects? We went from figuring out how to make a simple one-way gate for electricity all the way to building these artificial brains with billions of microscopic switches. This fundamental technology continues to shape our entire future. The only real question left is, what's next?